Welcome back. Okay, in our last lesson, we took the logic diagram exercise step by step and we arrived at a solution. Just to recap, a logic diagram is a picture of a sequence of items required to represent relationships in a flow from left to right. The farthest point left represents the starting point and the most distant point right, the completion point. In this lesson, we're going to take our completed solution and incorporate some basic aspects of composing what is known as a network diagram. And for our purposes today, it will be a closed network. A closed network has a single starting point and a single ending point, known respectively as the start and finish milestones. In our not to scale diagram here, they will be represented as boxes on either end. The start milestone is placed before the letters C, N, and A, and the finish milestone is after the letter X. This makes the diagram a closed network diagram because there is only one beginning point and one ending point. Milestones represent a point in time, whereas the arrows or line items that we have created in our example have a time duration. These durations are in units of time. They can be days, weeks, months, or even years. They can also be seconds, minutes, or hours. It really depends upon the type of activity or what the project is. For example, days, weeks, and months might apply to a construction project, whereas seconds, minutes, or hours might be used for editing audio, video, or something similar. Interestingly, years might be applied to one's lifetime. And we're going to talk more about charting things of a personal nature as we learn about the concepts of IdeaGrams, which resulted from the use of the network diagramming techniques being demonstrated in these initial videos. In our next diagram, we have added numbers above each letter. These numbers will represent the unit of time required to complete each operation. And for our purposes today, let's just say that they are in days to keep things simple. And the dotted lines represent the logic restraint. And logic restraint simply means the dotted line prevents something from proceeding until the prior activity or multiple activities are completed. Our next order of business is to calculate the total time needed for this project, being mindful of the logic in our diagram. Let's go ahead and start at N and follow its path towards X and add the durations along its path. Below the letters, I'm going to add the accumulated totals. Notice that I've placed the number at the end of the arrow and not at the center or start. This is going to signify that the operation or the accumulation of time preceding that operation has been completed and the time it took to do so. Also, I'm going to go ahead and place the times in at C and A as well. So let's get started. N plus E equals 10. So let's put 10 at the end of E. We could just keep going and add T and come up with 15. However, C intersects with T. And following the logic in the chart, it takes C 15 days or 5 days more to complete than N and E at 10. So we have to insert 15 before the start of T to show the difference in time. Moving on, we could add 15 plus 5 and get 20, and then add 5 and get 25. We're going to total up the other two paths before adding X to get our final total. The path starting at C is going to be a little more straightforward. C to P is 30, P to M is 45. And finally, A to J is 20. If we look closely, we see that once again, C crosses this path at W. Only in this case, C takes 15 days and A plus J take 20 days, so the larger number is the one we'll use. We now have 20 at J plus the 5 at W equals 25. So of our three paths, we can see that N to S equals 25, C to M equals 45, and A to W is 25. So we now know that X can't start until after the 45th day. When we now add 10 at X, we see that C to X is 55 days, or our most extended path. So this will represent our time of completion. And because it is the longest related sequence of events, it will be referred to as the critical path. The critical path is a sequence of activities that adds up to the longest overall duration. This determines the minimum time needed to complete a project. Our next step in this process is to design a two-scale logic diagram chart. A scale chart allows for a clearer overview of the project, and it's used to better schedule and organize our tasks. To build a two-scale drawing of a logic diagram, we first need to create a time ruler in days to assign our tasks to. With this in place, it is now a simple process of adding all the operations with their assigned days and making them conform to our new time scale. Now that we've added everything, we can finally see this project in proper perspective. Notice the dotted lines after S and W going to the start of X. We call this slack or float time. Slack or float time allows an operation's time to be delayed without causing a delay to subsequent tasks. In other words, T&S could conceivably take 20 days longer to complete without causing any issues with the rest of the project. The same is true of W. This example demonstrates the importance of establishing the critical path, because all other operations revolve around this core principle. We hope you've enjoyed these logic diagram lessons. Please stay tuned, as in our next set of videos, we will explore the concept of IdeaGrams, how to construct them, and their many uses. Thanks for watching.